Okay, guys, we are jumping into a new chapter. So our chapter is chapter 2 in our book, and we are going to learn about sets. So our first question that we have is probably, well, what is a set? So our definition that we're going to give to make sure that we all are on the same page is that a set is a well-defined collection of objects called elements of the set. So a pretty straightforward idea. Basically, it's just a list or a collection of things. And then we can do various things with sets. So it sounds like a simple idea, but it's actually a very, very useful idea, both in math and in general other applications. There are all kinds of times where we want to be able to have a well-defined collection of objects. So we got kind of two definitions happening there. That's what a set is, and then the definition of elements, the fact that those are the objects in the set. So when we start to talk about sets mathematically, we have three different options for how we can define them or describe them. So those are listed here. The first one is to just give a verbal or a written description of the set. So the description would have to be such that it clearly gives a definition of what would be in the set and what would not be in the set. That's sort of what we mean up top when we say it has to be well defined, right? If I describe it to you, you need to be able to understand what's a part of it and what's not a part of it. So for example, if I say something like the set of all great baseball players, it's not really well defined in terms of you being able to understand, well, what should be a part of it and what should not be a part of it. We could give a much more thorough description and say something like the set of all baseball players who have a batting average over 300, right? It's very well defined then. You can clearly determine what's in it and what's not in it. And notice all of those are just a description, just something verbal. So like a sentence that describes the set of blah. The next thing that we can do instead, and this is honestly one that we use pretty often, is what's called roster method. Now, even just hearing the word roster, you probably have ideas that come to your mind that are associated with that word, right? If you think about when you've heard of rosters, you might think of, like on a sports team, for instance, you might have a team roster. And if you think about what that is, well, it's literally just a list of everyone who's on the team. So that's what I want you to think about. When you think about that word roster, I just want you to think about the word list, because that's essentially what roster method is. What we're going to do is it's a list of the elements, and we have some descriptions of how we're going to list them. We're going to separate the elements by commas, so it'll be a comma-separated list, and we're going to write that list inside of what are called curly braces. So those are these two guys. You have seen those probably on your computer keyboard in the past, and they've shown up, but maybe you've never thought about when they would be used. This is a place that we're going to use them. So the minute you see a set of curly braces, it kind of is like the symbol way of saying, okay, the set of, and then the set is defined by just listing the elements. So it's clearly well defined of what's in it and what's not in it. So that's roster method. And then the third method is something called set builder notation. And I'm just going to put a pin in that for a second. I'll explain it here in a minute. So sometimes an example is going to help us put all this together. So I've put an example up here of three different ways that we can look at one particular set. So a verbal description of a set example is we could do the set of all months in the year, right? Just the way that I've described that, you now have an idea of what I'm talking about. I mean, January and February and so on and so forth. Now, we could represent that same set, rather than in this verbal description in a sentence, we could do it using roster method. So we're going to start off with an opening curly brace, and then I'm actually going to list every element that I want in the set. So those were the things that came to your mind when we read that verbal description. So I'm going to actually write January, February, March. Notice it's okay sometimes to use that dot, 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 the set of ellipses. You want to make sure that if you're using it, it's actually clear of what goes in that portion of it. So we could say, you know, we all understand that, okay, after March comes April and then May, so on and so forth, until we get to December. But notice we still have commas in between all of those. So we can specifically see those elements separated out. And then notice when we're finished with the set, we use that closing curly brace to end out the set. So that's an example of what we meant by roster method and what those symbols would look like. Now we've got that third method that I said I would put on hold. Here we are with it. It's kind of an interesting method. It's really useful in math when you're trying to describe things. It can be a very practical technique. It looks a little intimidating on the front end, but really it's fairly, for our purposes, similar to the verbal description. Where what's going to happen here is this is our general set builder notation. It's always going to kind of look like this, where then just this blank is filled in with some sort of description. So the way that we actually read this, it's essentially a sentence using symbols. The opening curly brace, just like it was with roster method, will read as the set of. So we have here the set of all x. So the set of all x's. Then we have this big upright bar that's read as such that. So we've got the set of all x's such that. And then you just read the rest of the sentence, such that x is something. And you give a description of the elements in the set. So in that sense, that piece of it is a little bit like a verbal description, except that we potentially might in there use other symbols, we might use other notations that we wouldn't necessarily say verbally, but rather we write them down as symbols. So that's all it is. So you read set builder notation as the set of all x such that x is blah. That's how you read it. And it's always in that form. So in our example that we just had above, the months of the year one, we would write opening curly brace x such that x is a month of the year. So x is sort of this placeholder for a random element in the set, and then you describe what it should look like. So that's an example of set builder notation. So we're going to go ahead and pause this video, and we'll jump into another video where we're going to try a few more examples. So hop on back here in a second.